In this video, we're going to have a look at reaction rate. When we say reaction rate, what we're actually referring to is the rate of formation of products or the rate of consumption of reactants. And a rate is measured as a change per unit time. So for example, if we're looking at the formation of products, it might be something like the number of grams formed per second, or the moles of substance formed per second, or the change in concentration of that substance per second. What this means is to measure reaction rate, we need to monitor the reaction over a certain period of time and have a look at the change in concentration or mass or amount of substance over that period of time. So quite often that data is collected and graphed, and we can tell a lot about the reaction rate by studying the graph of the reaction over time. And if we do that, what we're generally going to see is that the concentration of our products is going to increase over time, and the concentration of our reactants is going to decrease over time. And by looking at the slope of however we've measured it, so concentration, mass or number of moles versus time graph, we can see something about the rate. So basically, the steeper the slope, the faster the rate. So a graph such as this one would be constructed after taking these measurements over a series of time. So say every 10 seconds, the mass being produced would be recorded, and then that data is plotted on a mass produced versus time graph, and a line of best fit would be drawn in. Now this is where we can see something about the rate of reaction. So there's two different types of rate of reaction. So we can talk about the average reaction rate, or we can talk about the instantaneous reaction rate. So the average reaction rate is basically just the rate over a certain period of time, and you find it by looking at what the change in the quantity was, and you divide it by the time period. So this can be done by picking any 2 points. So in this example here, if we took the initial mass of the product, which was 0, and then we pick the mass that's been recorded after 60 seconds. What we're going to be able to do is calculate the average rate over the first 60 seconds. And you do that by finding the slope of this line. So the slope would be equal to the average rate over the first 60 seconds. And just to jog your memory, you find the slope by taking the rise over run. So you just need any 2 points, and you subtract the one y value from the other, and you divide it by the corresponding x value, subtracting by the other. So rise over run, or y2 take y1 over x2 take x1. And you're probably familiar with that concept from mathematics. Now we can also calculate the instantaneous rate of reaction, which is the rate at a particular point in time. So the instantaneous rate of a reaction is equal to the gradient of the amount versus time graph. So basically it's how steep the graph is at different points. So just by looking at the graph, we can see in these early points here, it's steeper, and as we come along through time, it flattens out. The way we actually calculate what the gradient is at those points is you pick a point. So in this case here, I've picked the 30-second mark, and you draw in the tangent to that graph. And then you just find the slope of that tangent. So just the same way as you find the slope of any straight line, you can just have any 2 points on that line, and the slope is equal to the rise over the run. And you can do that for any point on the graph. So in this example, if we found the slope of the tangent at this point, we'd be finding the instantaneous rate at 30 seconds, but we could just as easily during the tangent at this point here and find the instantaneous rate at 40 seconds. In the next video, we'll be having a look at factors that affect reaction rates.